In number 37, we want to find the sample size required to estimate a proportion. So we're going to use the formula for proportion. If the preliminary estimate is 0.24 and you wish to be 90% confident with a margin of error equal to 3 percentage points. So that's all the information we need. And we're going to use the formula n equals our preliminary estimate, p hat, times 1 minus p hat, times z sub alpha over 2 over the margin of error, and this part is squared. So p hat is our preliminary estimate, so that's 0.24. Oops. Then we multiply by 1 minus p hat times the square of this fraction. I'm going to put in the margin of error first, e, and that's 3 percentage points, so I'm going to make that 0.03 in the denominator. Now to find the z value, if we want to be 90% confident, then that means that we need the z value for 90% confidence. So that means 90% in the middle, and that means that there's 5% in each tail. So we're going to do inverse norm, and I'm just going to do a 0.05. I actually want the upper tail, but because we're going to square, it doesn't matter whether we get a positive or a negative here. So this gives me negative 1.64, and I'm not going to bother writing in the negative here because it's not going to make a difference. My answer will be positive either way. So I type this into the calculator, really just the way it's laid out here. For the fraction bar, you can use the division sign, and otherwise it's just like the way it's written there. So this gives us 545.09, and we always round up to the next whole number. So even though normally we would round this to 545, our correct answer is 546. One thing I want to point out, I rounded the z-score to 2 decimal places, the way it says in the instructions here. In your homework, I believe they have you round it to 3 decimal places, but they don't specify that in the directions, so they just kind of hope for the best with that. But they should point that out. That's what they're doing. So I think they're going to 3 decimal places. In some problems, it doesn't make a difference, but in others it will, and I think this one would make a difference. So on the test, I'll have you round to 2 decimal places. That's what we usually do with z-scores. So that was number 37. Now let's try 38. So in this one, again, we want to find sample size. We're using the formula involving proportion, so p hat, 1 minus p hat. This is given on the exam. Z sub alpha over 2 over the margin of error, and then we square. Now in this case, we're not given a preliminary estimate, so what do we do for p hat? In that case, we assume that p hat is equal to 1/2, or 0.5, because that way we're not assuming that it's small, like 0.1. We're not assuming that it's large, like 0.9. We're just going for smack in the middle, which is 0.5. And then we have 1 minus 0.5. And then we need to find z sub alpha over 2. So I can do that. In this case, we want to be 99% confident. Means 99% in the center. And that gives me 0.5% in both the upper and lower tails. And remember, that's 0.5%. So when I do inverse norm, I'm going to calculate inverse norm of 0.005. And in that case, I get negative 2.58. Oops. Again, I'm going to just go ahead and drop the negative on that. So I make it 2.58 in the numerator over the margin of error, which is 5 percentage points, so that's 0.05. A lot of 5s going on here, so be careful. It's easy to get confused. The number 5 seems to come up an awful lot here. So let me point this out. So we have the 0.5 here and 0.5 here. That's the same 0.5, and that's because there's no preliminary estimate. Then we had the 0.005, and that came from 0.5% because that's the area in the upper and lower tails. And so we take the inverse norm of that to get 2.58, so that gives us our z-score. And then we have the margin of error, which is 0.05, because this says 5 percentage points, which is 5% or 0.05. All right. So when I do this, oops, and I got a square. So when I put this into the calculator, I get 665.64, and so that gives us 666 as the appropriate sample size for that problem. Next, in 39, oops. Here, again, this works the same way. Well, I shouldn't say the same way. We're using a different formula here. So we're using n equals z sub alpha over 2 times sigma over the margin of error, and then that's all squared. So when I said the same way, I was thinking about that we have to find the z-score there. So in this case, it's a z-score for 98%. So I'm going to take the inverse norm of 1%, and that gives me, 2.33, or negative 2.33, I should say, but I'll just write 2.33 here. And sigma is 8, and we're dividing by 3. This is an actual 3 now because we're finding a sample size required to estimate a population mean. So that's why we're using a different formula. It's about a mean rather than a proportion. And I take this all and square it, and I get 38.60, and that rounds up to 39. And that's my final answer. And then 40 will work the same way as 39, so I'm not going to work that one out. Just the numbers change, so we've got sigma is 3.5. You want to be 92% confident, so in that case, we're going to have a z-score of, I think it's 1.75. Yep, 1.75. And then the final answer for that one is, I wrote it on a piece of paper here, 151. So it's 150.0625, which rounds up to 151. So that's how you do those problems.